Good morning, students. Previously, we have seen the air standard efficiency, then air standard cycle, fuel air cycle, and actual cycle. Now, here we are going to find that if we plot the graph against the thermal efficiency versus the mixture strength, then we are finding that air standard efficiency uses only air as a working fluid and considered reversible processes. But in actual practice, it is not all the processes are reversible. So in air standard cycle, air is a working fluid and we are considering it as a reversible processes. Now, so that's why these air standard cycles have highest and constant efficiency with respect to mixture strength as we are considering the air fuel mixture. And if you see in this diagram, this is for proper stoichiometric mixture. At this point, you're finding that the line is horizontal. Okay. And if we go to the left side of this, we are getting linear mixture. And if we go from this stoichiometric point towards right, we are getting the rich mixture. So this is related with the air standard efficiency or air standard cycle. Next point we are going to see, if you see this curve, we are finding that fuel air cycle consider only specific heat and dissociation losses, as we have discussed previous slides. So it has lower air standard efficiency than the air standard efficiency. Okay. And also if you observe, this is the actual curve. As in this actual curve, actual cycle takes place in where all the losses including, we are considering the pumping losses, specific heat losses, timing, dissociation loss, frictional loss, and unburned fluid loss, and other losses also, such as a bending and all those losses. So if you find that, if you are comparing the points related with this stoichiometric air fill point, at this point, you are finding that air standard cycle has the, or air standard cycle has the higher efficiency, and second number fuel air standard cycle. Next, third one, actual. So we are considering all the losses, or all the losses we are observing in the actual cycle. So that's why it has the efficiency lesser than both these two. So this is the effect of air fuel ratio on the thermal efficiency on air standard, fuel air, and actual cycle. So this is the last point in the first unit. So this is the end of your first unit. So if you have any queries related with the first chapter, you may free to ask me. Okay. Now, Sushil, I am audible, na? Sushil? Okay. Now we are going to start. We are going to start our second unit. Second unit is the SI engine. And we have discussed in the comparison between the SI engine and CI engine, we are using the carburetor in case of the SI engine to prepare the air fuel mixture. Okay. So first of all, we are going to see that in the SI engine, or we have seen it also, what is happening in the SI engine. Now, in SI engine, usually we are using the volatile fuels such as petrol, alcohol, and benzol, etc. Such kind of the fuel we are using. Okay. So in this fuel, the mixture of fuel and air is prepared outside the engine cylinder. So as it partially evaporated mixture is supplied to the engine, the mixture is prepared outside the cylinder, and which is never homogeneous droplets. Okay. So the droplets of fuel continues to evaporate during the suction and the exhaust stroke over there. So the process of formation of mixture is very important for spark ignition engine. So for the engine to operate efficiently under all working conditions. So which are those working conditions? We are going to discuss on the latter here. Okay. So few definitions first we have to require before seeing these carburetors. Okay. So first of all, what is mean by carburation? This definition is very much important. So the process of preparation of mixture of atomized fuel and the air before admission to the cylinder is called as the carburation. So we are calling the preparation of mixture of atomized fuel and air before it will be entered into the cylinder. That process is called as the carburation. And the what is meant by carburetor? If we see that the device which supplies the metered spray of fuel mixed with correct amount of air for efficient combustion in the cylinder at all operating condition is called as the carburetor. Keep the difference between these two. Process of mixture preparation of air and fuel before entering into cylinder is called as the carburation. And the device which supplies the metered spray of fuel mixed with the correct amount of air for efficient combustion in the cylinder at all operating condition is called as the carburetor. So this is the basic definition of carburetor and the carburation. So first, we are going to see the working of the basic components of the uh, carburetor system. Okay, or we are saying that how it is operating at the all the conditions. Okay, so basic fuel feeding or induction for the SI engine we can see over here, but its function is to supply partly vaporized mixture of fuel and air to a various cylinder. If we are considering multiple cylinder, at various cylinder, it has to supply the proper partly vaporized mixture to the engine. So it consists of supply of fuel from fuel tank to air, from surrounding to carburetor, in which the fuel is partly evaporator, and the partly evaporator fuel and air mixture from the carburetor is carried through the pipe, and that pipelines are called as the intake manifold. Okay, keep in the mind, intake manifold means what? The fuel which carries the fuel air supply from the carburetor to the suction of the cylinder, that is called as the intake manifold. Okay, and partial evaporation of fuel is also takes place in the intake manifold at the inlet wall. So we are finding that if we see this simple diagram of the simple carburetor, if you see this simple carburetor, this is the float in float chamber with venturi, then venturi and the main jet system. If you observe this figure carefully, in this float chamber is open in the atmosphere. If you are observing one float for the float chamber, we are giving one hole at the top. If you see the fuel tank of your motorbikes, if you observe though that cap carefully from this side, there is a little gap between these two, so that the atmospheric pressure will act on that fuel, or there is a small hole in the cap of your petrol tank. Okay, so atmospheric fuel, there is a atmospheric pressure will act on the fuel inside the tank. Okay, so how it helps to create the pressure differential, that we are going to be discussed now. Okay, fuel is supplied from the float chamber. Okay, from the float chamber over here through the strainer from the fuel tank with the help of fuel pump. Now if you observe here, this is the fuel tank, float we have provided, needle system is provided, and the pipe coming from the fuel tank to this float chamber. Okay, whenever the level inside this float tank is reduced, at that time this needle valve will be open and fuel from the tank will flows down towards the float chamber. Okay, so the rising of the fuel inside this float chamber will rise this needle valve system, and it again closes this fuel supply. Okay, now the this if you observe here, one jet we have provided, and the jet tube consists of the main nozzle to which fuel is supplied from the float chamber to the main jet. Okay, so from this, for this jet tube, this is the jet tube, and at this jet the nozzle we have provided. Okay, and which supplies the fuel from the float chamber to the main jet over here, and the suction of the engine is drawn through the choke tube and passes through the venturi. Since the area of cross section of throat at the venturi, here we are finding that there is a reduction of the area over there. Why we are providing such kind of the reduction of the area? Because pressure at the main nozzle reduces and the velocity of air will increases over here. And due to this pressure differentiation, we are finding that from the main nozzle, the pressure in the float chamber, the fuel from the float chamber is supplied to this main supply system or main nozzle. Okay, where mixture of air fuel will be prepared. Okay, as the venturi vaporization, the petrol fuel partially, which is then evaporated by the heat intake manifold or from the heat taken from the cylinder wall. So we are finding partial evaporation will be occur before entering into the this here. Okay, so a petrol engine is quantity governed. Keep in the mind, petrol engines are quantity government. What is my quantity governing? Quantity governing means the amount of charge delivered is according to power delivered by the engine at particular speed. Means you are getting that this is achieved by the throttle wall. This throttle wall we have provided over here. As our speed or load on the engines changes, as per that condition, we are saying that the opening and closing of the throttle valve will be maintained over here. Okay, when the throttle valve opens, more air will be flows. Okay, through this venturi tube, and more quantity of fuel air mixture is delivered to the engine, and engine develops here more power. And reverse action, if this is the closest, then less air will be flow and less air fuel mixture is the prepared over here. Okay, so the pressure at the throat under fully open throttle condition lies between 4 to 6 mm of Hg below the atmospheric condition. Because below the atmospheric condition, why I am saying that? Because atmospheric pressure acting on the fuel in the fuel tank, and here we are creating, due to variable area cross section, the pressure below the atmosphere. So due to this pressure differentiation, the fuel will be sprayed inside this throat over here. Okay, so keep in the mind this level of this fuel in the float chamber and the fuel in the this jet tube is you are finding at same level, because it is very much important. If you show the flow tube tip at the higher side, there will be there be pressure differentiation will not occur because this point is going towards the higher side, so it will not gives the proper pressure differentiation. Okay, so that's why this is very much important. The level of the fuel in the float chamber and in this the tip of this jet tube is at same level. So while drawing the diagram in the examination, you have to keep in the mind some, because students are showing this jet tube tip at this point, or they are showing at the lower side. So what is its effect? If you show in the lower side, then there is a continuous supply of the fuel, because it does not shows the pressure differentiation. Though there is a fuel, though there is a flow of air or not, if partial air will be flow, it will flow maximum fuel. And if it is the higher side, then at small opening, it does not showing the spraying of the fuel inside this throat chamber. So this is the simple construction and working of this simple carburetor. Now, if you observe this simple carburetor, what are the disadvantages or drawbacks you are finding? So one by one we are going to discuss. So it provides the required air fuel ratio only at the throttle position. When it is open, when it is closed, at that time, when it is closed, there will be no any kind of the fuel air supply. And when the throttle is open, at that time only it gives the air fuel mixture to the cylinder. So throttle position and the mixture is either richer or leaner. It will depends upon the throttle valve opening and closing. Okay, so this is first drawbacks. Second one, if provides increasing richness of air fuel mixture as per the speed of the engine increases. So due to this reason, throttle valve opened gradually and the pressure at the venturi throat decreases. So decrease in the density of air is increases the velocity of the air. So the quantity of fuel flow remain constant. So air fuel ratio decreases with increase in the speed of the engine. So this is the second drawback of simple air carburetor. And third one is the, if speed is too low, as I have discussed, so we get the lean mixture, which is not sufficient to ignite the mixture. Because if you're finding that at starting position we are applying the choke, why we are applying the choke? To open the maximum throttle over there. But if in the carburetor, if you are finding that at starting condition the opening of the throttle valve is less and the requirement condition at the starting is the rich mixture, and which does not satisfied in this simple carburetor. So where we are using this simple carburetor? Simple carburetor we are using for the small stationary engines which runs at the constant speed. So some modifications will be required in the simple carburetor, such as you have to provide the starting choke, then main metering or idling system, acceleration, part load reading, economical range, that is called as the metered pin method. Okay, quality control by suction and pressure reduction. So these simple modification we are going to do in this simple carburetor, and we are going for the further modifications. Okay, this is another diagram so of the simple carburetor. Now here you can get clear idea. This is the actual diagrammatic view I have shown. So as we have discussed, fuel from the fuel tank is supplied. In this tenor, the foreign contaminants will be removed over here, and fuel, this is the fuel in. Now atmospheric condition is acting over here. So this, you have seen, this is the float, and this nozzle, if you are seeing that, this is the tip of this float. We are showing the needle over here, but needle pointer in this diagram, needle pointer have to show at this point, okay? Because we are applying the atmospheric pressure on this fluid from top side, and in the float chamber you have to be applying the needle system, and if the fuel inside this float chamber will be drops down, at that time float with needle will go in the drop condition, and fuel from the fuel tank is supplied inside this fuel tank over there, okay? So this is the float chamber arrangement. Now here you are finding that two walls we have shown. First wall we are calling it as a choke wall, okay? And second one we are calling it as a throttle wall over here, okay? So in this condition, we are using this choke wall at the starting, as I have discussed in previous diagram, what kind of the improvement required, okay? So at starting condition, we are finding that due to starting condition, as air is flowing maximum over here, pressure differentiation prepared, and at starting condition richer mixture will be supplied over here, okay? So that's why this choke wall we have provided. So throttle wall we are opening as we are accelerating over the here. So at the starting, when we are using the choke, rich mixture will be supplied to the engine cylinder. Now how pressure differentiation takes place, now you are going to see. So here atmospheric pressure from the atmosphere will be acts on the fuel inside the float chamber, and here you are finding as air is flowing, it has the higher velocity. So at the throat chamber, velocity decreases and pressure will be, velocity increases and pressure will be reducing over here. So as here pressure is below atmospheric, and here pressure acting is the atmosphere. So due to pressure differentiation, the fuel will be spread inside this air. So that's why this, we are saying that venturi is the prepared. And at this throat section, the opening of this jet will be provided over here. Keep in the mind the fuel inside the float chamber, and you have to show this spraying jet height at proper level, okay? So this is the simple carburetor diagram. As I have discussed, you can draw this diagram or this diagram. It is better to draw this diagram and explain each and every point related with the simple carburetor. As we have discussed the construction and working, as we have discussed the drawbacks of simple carburetor, and as we have discussed the application of this simple carburetor. So have you any difficulty regarding this? Kahi shanka hai ka?
No, sir.
Okay. So we are going to conclude today's lecture. In today's lecture, we have seen the effect of air-fuel ratio on the thermal efficiency, air standard efficiency, and fuel air cycle and actual cycle. So while discussing this, we are finding that in case of the air standard cycle, we are considering that all processes are reversible. So it has the maximum efficiency at any point. So we have plotted the thermal efficiency and mixture strength graph, and at stoichiometric point, we are finding on left side linear mixture, on right side there is a richer mixture. But if you taking the stoichiometric air fuel ratio at this point during the air standard cycle, we are getting the maximum efficiency because we are considering all the all the processes are reversible, and we are considering this showing the highest efficiency over here. And fuel air cycle, we are considering only two factors. There is a specific heat uh, affecting and the dissociation losses. So these two we have considered. So it has lesser than the air standard efficiency. But in actual cycle, we are observing that there are pumping losses, specific heat losses, timing losses, then dissociation losses, frictional losses. So in actual cycle, there is the lowest efficiency. Okay, so we are finding the lower efficiency in the actual. So this point we have covered, and here we have completed unit number first. Next, we have started the unit number second. So in this unit number second, why carburetor is required? We have discussed what is by carburation, what is by carburetor. Carburation means what? The preparation of the mixture at the outside, the process of preparation of the air fuel mixture outside the cylinder before entering the charge inside the combustion chamber, that is called as the carburation. And the device which is preparing this mixture which is preparing the proper or stoichiometric mixture at various load condition, various speed condition, that device is called as the carburetor. And we have seen the constructional features of the simple carburetor with various load condition over here. And next we have discussed preparing the mixture with desired air fuel ratio at the various load conditions. So simple air fuel mixture or simple carburetor working we have seen, and this we have seen which works on the Bernoulli's principle over the here. Okay, so this is the simple carburetor we have discussed, and after that we are going to discuss the mixture requirement in the next lecture. So have you any difficulty regarding the today's session? काही शंका है का?
No, sir.
Okay, so we are going to end our session here. Okay, thanks for attending the session. So this is the preparation leave week.
Yes, sir.
Whom is declaring?
What, sir?
Who is declaring this preparation leave?
Group वर आलता, sir.
Okay. So I haven't observed any such kind of the things on the group. So I will see, and seeing that the class teacher is issuing any notice regarding the preparation leave. Because if you see that for the second semester, there is a lesser timing is available. We have. Okay.
Yes.
And we have to complete the 4 units. Now we are in the second unit. Okay. So we have to complete all the 4 units. So that's why this week is very much important, because examination started from which date?
4 to 8 May.
4 to 8 May. Then there is more timing. Okay. So in this week, we are continuing the thermodynamics lecture, because before the examination, we have to complete the 2 units at least. And after examination, again, you have to face the second semester examination, because they are going to give only 15 days after this first examination. So how we are going to complete this syllabus? There is only short duration is available. Okay. So I will discuss this matter along with your class teacher and the HOD, because 4 hour because 30 to 35 minutes sessions we are taking. Okay, so there is no any difficulty regarding this to attend the lectures. Okay, so thanks for attending the lecture. So I'm going to stop the lecture here. Thank you.